Hi, geometry. We're going to do 11.5, which is volume of pyramids and cones, which is all actually one of my favorite ones. So I'm super bummed we're not together because I love using this because usually I have some water and I like to show this because you've learned right here how to get the volume of a prism. It's the area of the base times the height, right? And you've learned how to get the area of this prism. It's the area of the base times the height. Well, what happens if I take something, and put that right on top there, and I have a pyramid? So it has the exact same base, if you notice. It fits perfectly on top. And it has the exact same height. So it's the same height tall. Same thing over here. I've got the same base. But when I put it next to it, it's also, you can't tell probably, but it's the same height as the cube there. And if I were to take off these ends, and if I were to take this and pour water into the prism, how many of these pyramids do you think it takes to fill the same prism that has the same base and the same height? What would you say? 2? 3? What do you think? Well, I will tell you, most people say it's going to take 2. The actual answer is 3. Yes, indeed. It takes 3 of those pyramids to fill up the prism of the same base and same height. So what does that tell you about the formula? Okay, so the formula of those prisms was area of base times height, right? So if a pyramid, it takes 3 of those. What's the formula for area of or volume of a pyramid? Wow, 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 wow. That's right. 1/3 of the base times height is the pyramid, right? Because it takes 3 of them to get, that's prism. And if we filled it up, we only filled up 1/3 of it. So that's where that formula comes from. I think that's always kind of fun. It never fails. The kids always say 2. And I'm like, nope, it is 3. And then they're all like, oh. So you'll have to do some imagining with that. But let's try it. A sports arena shaped like a pyramid has a base area of 300,000 feet squared, a height of 321. What's the approximate volume of the arena? So 1/3 base times height. That was easy. They gave us the base times the height. They gave us everything we need. And this really simplifies, doesn't it? That's 100,000 times 321 would be 321 100,000s. 1, 2, 3, 4, 5. Right, because this is 1, and then we need 321 of those. So, all right, and it is feet cubed. All right, now it says, what's the volume of a square pyramid? Okay, and they don't give you the area of the base. They give you the base edges of 24. So I'm going to write my formula down. And remember, it says it's a square pyramid. It's important that you look and notice that, because then when you see base edges are 24, you're like, oh, good, I can get the area. 24 times 24 is 576. So now I've got that. Oh, and it gives you the slant height. Is that what we need? No, we need the real height. There's no L here. So I want you to picture in your, oh good, I have a square pyramid right here. And they're giving you this distance on the side of it, right down the side here. And then we also know the distance to the middle, don't we, and across. It'd be half of that length of a side. So we're going to actually have an actual triangle in there. This is our slant height of 13, and we know this is half of the edge, so we need the height. And that happens to be one of those perfect Pythagorean triples. Does anybody remember what that comes out to? Because it's really nice and even. It is a 5. And if you don't remember it, you can use Pythagorean theorem the long way and solve. So we'll go over here and put the 5 in. Comes out even to 960 meters cubed. All right. Now, just getting this cord out of the way and writing on the wall at the same time. Oh, that's no good. Okay. Now we're going to do a cone, but guess what? Cone is exactly the same. Okay, so if you had a cone with the same height and the same base, it's going to take 3 of these cones to fill it. So the volume of this is 1/3 of the volume of that. Hence the reason we have 1/3 of the area of the base times the height. Isn't it slick? It just works so well together. All right, so they tell us the height and radius of a child's teepee are 6 feet and radius is 7 feet. What's the volume? All right, let's do it. 1/3 pi radius, they gave it to us, is 7. Height they gave to us is 6. 1/3 of 6 is 2 times 49 is 98 pi. Oh, cube nearest foot. So let's see, I looked that out before, and it is about 308 feet cubed. All right, last one. Volume of an oblique cone. So it's angled off to the side, although mine doesn't really look like it. But they actually gave you this side, which is also perpendicular to the bottom. So that side actually is the height in this case because it leans off perfectly. It sets up. So I'll put my formula down. Radius is right here at 6. Height is actually the side in this case. It's rarely the side. It's rarely angled perfectly so that the side is the height. But just remember, whatever is perpendicular to that base is your height. All right, so I've got 36 times 4 is 144 pi. Nearest meter, so it's 452 meters cubed. All right, so I hope that helps. Have a wonderful day, geometry students. Bye-bye.